pretty good. So are there any questions from the quiz or from homework stuff?
For the homework on 7.2,
Yeah.
on 6 through 12, why is it like 7 through? How do we do the first one? It's number 6 and 7.
You said 7.2.
0.2.
Okay. What has happened? There. Oh, Jeff. Yeah, that's why I can't see anything. 7.2.
I wasn't sure if we're still supposed to find the hypotenuse or like say.
And I'm sorry, number what now?
Number 6. It's like they're all set with the opposites.
Yeah, so this is what we kind of pointed out yesterday. I need to firm this idea up. But we noticed that cosine of 60 degrees was the same thing as sine of 30 degrees. So let's kind of firm this idea up. Let's see. Now you could be looking at that problem and saying, Jeff, it don't say 60 degrees. Because there's a general relationship that comes out of that. So like, sure, B and theta. Okay. Can somebody tell me what sine of theta is? Yeah, is sine, careful, is the angle in the base? The angle that I'm talking about, is it in the base? Is it on the bottom of the triangle? Yes. Is everybody with me? So that's just in case you don't know what I mean when I say in the base. The angle I'm looking at is in the bottom of the triangle. So which side does sine relate to? What side is sine like? Does anyone remember? Sine likes one side, cosine likes the other side. Sine likes the y. Sine likes the y. Why? Because that's how we define it. We just define this function into existence. The same way we define what a square root function does. We define what a sine function does. And we decided the sine function is what? What side over what side? In this case, 3 over 5. So it's the y side divided by the hypotenuse. It's kind of like the percentage. All right. So if you look at 5 as the total amount that I have available, how much of that is in the y direction? 3 out of 5. So sine is literally kind of like a percentage of the hypotenuse that's in the y direction. Okay, I like it. So what's cosine of beta? The way that I taught this, what's the one thing you have to do? I'm sorry, not beta, but b. I went to Greek there for a second. What's cosine of b? What's the one thing you have to do the way I taught this? Flip the triangle, right? So now, what is cosine like? Do you see how, what became x now? What became x? 3, which is what used to be y. So of course, those are the same outputs, yes? Because if I rotate the triangle, then I'm going to get the other number showing up, right? The first number is going to suddenly become the one that trig function needs. Can anyone tell me what theta plus b is? Don't overthink it.
3/4.
How many angles are in that triangle?
3.
3. Do I know what b is? Do I know what theta is? Do I know what the third angle is? Yes. How big is the third angle? 90. How many total degrees in a triangle?
180.
So what must the other two angles add to be?
90.
90. That's the only way to make 180 in there, yes? Okay. So what this tells us is if I have sine of, for example, 11 degrees, let's say that that's equal to, you can do it, Jeff, w. What is cosine of 79 degrees? Well, do these two angles add to 90?
Yeah.
Yes. So when two angles add to 90, sine of one and cosine of the other one are the same. So if sine of 11 degrees is W, what's cosine of 79 degrees? W. And actually, once we get into unit circle, I'm going to kind of point out a nice visual as to why this is true, but we see this from just the idea that if I rotate the triangle, what was y is now x.
So every time the sine and the cosine have the same.
The angle that they're talking about adds to 90. They'll have the same output.
And if they have a different output from one another, that's a 30, 60, 90?
What do you mean?
Like, if the. Like
Does
when the
anyone
line-
remember what sine of 30 degrees is? We proved this the other day. 1/2, take guess. Does anyone remember what cosine of 60 degrees is? Okay, there you go. What's 30 plus 60? Yes. Just because if I rotate the triangle, what was the y side is now the x side. So of course sine and cosine will have the same output for the two different angles in the triangle. Okay. We're going to firm that up later when we start drawing the unit circle. It's going to be a little more apparent. I'm going to give you a nice, hopefully nice, way to memorize the values. So you guys are going to have to get to the point where if I said, what's the cosine of 45 degrees? 1 second, you got it. You've got to figure out how to memorize this. I hate memorization also. I can't remember if I told you my story about that's why I suck at biology, because it's mostly memorization. I hate that shit. So that's why I try to come up with stories, I try to come up with patterns, I try to come up with some other way than just writing on a flashcard and going, no, I hate that crap. I don't know how you guys memorize things, but I had to write it over and over and over again like I was in trouble at the board. Jeff wasn't bad, but we did it. I'd have to write over and over. No? Okay. I don't know how you guys do it. Is that better for that problem? So now this problem we were looking at, what was it? Yeah. So cosine of 34 degrees is the same as sine of what? What's got to be true about these two angles? They have to.
34.
What's true about the two angles to make the outputs the same? The two angles have to?
Be the same.
No, they don't have to be the same. No, definitely not. They have to add to 90. So cosine of 34 equals sine of what? 56. Why? Because what's 56 plus 34? 90. Okay. So that's just a consequence. It's kind of silly. We should expect like really simple little things like this because of the way sine and cosine are just ratios of triangle sides. So of course there should be some really basic ways that they interact. They're just ratios of sides of a triangle. So if I turn the triangle, all of a sudden one of them becomes the other one. That's all this is really saying. Okay. So I appreciate that, so when you're in the homework, that makes me feel good. Anybody else have questions from home? Okay. That part troubles me. So some of this stuff is a little bit freaky, like the next section of homework, yeah? All right, here. I'll be a nice kid. I'll pretend like I'm a student for a second. Hey, Mr. Waller, what the shit's up with the problem starting at number 10? I'm like, oh, okay, first off, dude, calm down. This section is deceptively difficult. Let's just take the first one, number 10, because I can't remember what I assigned. So if this is a homework problem, enjoy it. Cosine B is 4/5. You can draw a representative triangle from that, yes? So first off, when you draw triangles for this section, the most important thing is that this is C. If this is A, this is A. If this is little b, this is big B. That's the most important thing. It's just the convention. It kind of makes sense. We want the big ass B mouth to have the little B stick in it, so they go together. That makes sense. So when they give you a problem with this, in which I've already forgotten, what is it? Cosine B, it said is 4/5. Yeah, there. And then it said A is 10?
Yes.
Okay. What relationships do we know? We know what cosine means, yes? What is cosine defined to be? The ratio of what to what?
X over
X over hypotenuse. Kick ass. Sine likes Y. Cosine is the other guy. If you want to make a little rhyme out of it. Why is that true? Because we're the humans. We made that shit up. We said, oh, look, a triangle. I can make a bunch of ratios. Oh, my God, it's a function. Let's give it a name. Okay, let's give it the worst name ever. Sine and cosine. Yay. I need you with me. This is what we as a human race did. We did this. So now, those of us who weren't around, we just have to memorize it. We're like, okay, these guys already made the decisions. We have to memorize it so we all know what the hell we're talking about. So cosine goes like x. X out of the hypotenuse. Sine goes like y. That's going to become huge in just a bit. A lot of what we're doing is going to become a lot more apparent when I can draw that unit circle. This guy, a representative triangle. It's not going to be the triangle, but a representative triangle. What'd you just tell me? Where should 4 go? I'm going to draw this differently. This is bad. I'm going to put my B in the base. Put my B in the base because that's the angle we're talking about. So which side is 4? A. And which side is 5? C. Man, they really made this worse than it had to be. Maybe double check.
Maybe.
4/5. A is 10. Yeah, okay.
What is A equals 10?
All right, you ready? Okay. I need you guys with me. All right. Okay. Can somebody tell me what's the sign of B?
3/5.
3/5. Is that cool? What if I double the size of this triangle? Pretend like it's the same triangle. Then everything's doubled, yes? Isn't that silly? What's the sign of B now?
Still 3/5.
All right, so when I tell you that the sine of an angle is 3/5, does that mean the triangle it actually came from has a 3 and a 5? Not necessarily. Does this triangle have a 3 and a 5? No. So I desperately don't want you to make a big deal out of this. If I say sine B is 3/5, I have no idea how big the triangle was it came from. What I do know is the ratio reduces to be 3/5. Okay.
Thank you.
You're welcome. So I know that cosine B in general in this here is going to be B over C. Is that cool? Cosine B is B over C. I like it. And now they also tell me what A is. And I think the question, what was the question? Oh, the lengths of the missing sides. Oh, okay. Boop. So here's what's funny. If A is actually 10, and that's a back, let me ask a different question. What if they would have said A is 12? What if they said A is 12? So if A is actually 12, how much bigger is the triangle that this came from?
3 times bigger.
3 times bigger. Do you guys see that? What is A currently in our representative triangle that I can take straight from these numbers? What is A currently? 4. How much bigger would I have to make it? How many times bigger if they told me, oh yeah, by the way, the actual triangle it came from, A is 12. How much bigger would it have to be? 3 times bigger. So then what would this side be?
15.
15. And then how you get this side? Old Greek dude. Once you have two sides of a right triangle, you have all three because you got old Greek dude. You with me? Don't leave your house without old Greek dude.
So this problem we
I
need
need you to understand two things. This book is free. And this section, I always forget. This section is deceptively hard. This section of the homework. So don't feel bad if it doesn't make immediate sense. For some reason, I don't know why, the author had a bad day that day. And they're like, yeah, I'm just going to make this suck. This section is a little bit harder than it probably should have been. So the easiest way to do this problem to me, if this was 12, that's easy. Why is it easy if that's 12? Because I can see how many times bigger. In fact, how did you get 3 earlier? 12 divided by 4. So how many times bigger then is the actual triangle if this is 10? How many times bigger is it? How do you determine that? 10 divided by 4. What's 10 divided by 4? Yes. 10 divided by 4 is 5 divided by 2 is 2.5. So it's 2.5 times bigger. Yes? Does anyone know what this last side has to be? It says something 4, 5. 3. And this is not the right triangle. I need you to understand. This is like the reduced triangle. Like if I took all the ratios and I reduced them. Yes? So this is what it looks like reduced. We just figured out how many times bigger this one is, right? How many times bigger is this one? 2.5 times bigger. And they already told me one side is 10. All right, well, how do I figure out how long the hypotenuse is now? How do I figure out how long this is? 5 times 2.5. Yes. And how do I figure out how long this side is? Or just multiply by 2.5. Yeah, you could use Pythagorean theorem, but why? If I know I have a triangle that's 2.5 times bigger, I just multiply every side by 2.5. Yeah. So on that section, you could use Pythagorean theorem if you need to. You could use this idea of ratios to figure out how many times bigger it is. Okay, that little section should probably have been towards the end of the homework to say, hey kids, this is going to be a little harder than normal. So if that one section is giving the most trouble, that tracks. That's the way it should be, because that's not easy. Every now and again, this book will do that. Like the first 3 questions are the hardest, and I'm like, okay, that's backwards. Yes.
I got a different answer because I used Pythagorean theorem on the original, which is I did 4 squared plus b squared equals 5 squared. And
Sure.
I got b equals 3, but if you
I did get b equals 3.
3 times 2.5 is
And of course, that's how much bigger is the actual triangle? 2.5 times. So if that side is normally 3, I would multiply it by 2.5. Yes? So if you want to use Pythagorean theorem to get this side instead, you would do b squared plus 10 squared equals 12.5 squared, because that's the actual triangle that we're talking about.
But on this one, 3 is the answer, though, right? Because that's like the missing side, or is it? Do we need to?
It is definitely not 3, because that's not the triangle they're talking about.
It's just a,
Which triangle has a equals 10? That's the triangle they're talking about, yeah. Okay. Let's leave that for a moment, because that's, like I said, that's a harder problem. We're still in the basics. Okay. They just chose to do things a little out of order. Anything else from homework that's not from that little section? And I'm the one that asked the question for myself, but. So just to remind you guys, several things. Is it too late to turn in quiz 1 corrections? Nope. Will you get as many points back as you could? No. Could you turn it in on the day of the final and still get some points back? Yes. Okay. Right? All of that is true. Are you going to get a lot of points back if you do that? No. But you'll get something, and it's going to be review, and it will help you get ready. Are you with me? There's a method to all of my madness, as far as I can tell. And that's from my perspective, so always let me know if you think otherwise. Homework. Can you turn in early homework? Yes. What's the most immediate thing you should be working on right now then? The recent homework. Yes? So if you haven't finished chapter 6, forget about it for right now, because what's coming? What's the next big thing coming? Test, and what's that test going to be on? Chapter 7 and 8. So what's the most important thing to be working on right now? 7 and 8, right? And we're not in 8 yet, but we get into chapter 7. Are you guys with me so far? If you do corrections, do you just turn them in and never talk to anybody? If you do corrections to a quiz, you just give them to them? Or what should you do in the middle? Check it with who? Anybody walking around. No, it's not.
The science center would you...
Yeah, the math science center. You can give it to me and say, I'm not giving this to you, Jeff. I know it looks like it, but can you just tell me if these look okay? I'm not turning it in. You guys with me? And I'll tell you which ones need work still. It's crazy. So I know I've said all this before, I know. Right? I just gotta remind you guys, the reason I do that is my philosophy is your grade should follow your understanding. And the grades are always set in stone if they don't do that. I also can't let grades change forever. So this is a little bit of a balance, right? So make the most out of it. If you're going to make corrections, get the most out of it you can. Get help. Okay, I like it. All right, I'll stop. You guys look really beat up. I'm sorry if you're having a rough semester. I really am. And I'm sorry for whatever contribution that I've done, but I have to remind you, you signed up for this. Okay. One other thing I want to say. Well, I almost hesitate to say this, but I told my 171 class about this. Math 171, by the way, is like this class, just kind of like trimmed down a bit. I want everybody to really understand this. Everyone in here could have gone directly into calculus, if that's what you need to take. Are you guys aware of this? You could have gone into calculus by taking Math 180, which is calculus 1, with Math 080, which is a support course. You with me? In fact, the state might eventually kill this class and say, if you want to be a STEM student, start in calculus, good luck. And then they'll have a workshop about how do we get more STEM students. I'm like, this shouldn't be doing. So, you technically could fail this class and still take 180 with 080. If I were you, I wouldn't, because then that's like 6 units of a failed grade on your transcript. That's not good. Are you guys with me? But you could. You totally could. Okay. Are you guys all with me? Because I doubt you get this information well. Supposedly you're trying to communicate this kind of stuff, but they're not. I am not saying you should. I am so not saying you should. Because my God, when you go to calculus, you want a lot of what we're doing here to be second nature, so you can focus on the calculus. If you go into calculus without knowing this stuff, holy shit, you're gonna have to learn both at once, and that's insane. Yes?
I was told that calculus has like very little to do with recalc and it's until calculus 2.
No, whoever said that is so wrong. Oh my God. So, what do we do a lot of? What do you say is the number one thing we do the most of in here? I'm very curious about this answer, by the way. What do we do the most of?
Contemplate life.
Huh?
Contemplate life.
I'm sorry?
I said contemplate life. Graph.
Okay. Did you say contemplate life?
Yeah.
I understand. You sit here and go, what led me here? Graphing is what you said, yes. Totally. In fact, I don't know if I've told you this, but what's the purpose of 176? The purpose of 176 is to be graphing hell. That doesn't mean I try to make it horrible, and I should stop saying that. But in a way it's true, because when you get to Calc 1, you're gonna have to draw little sketches of things for yourself. And if you don't know what causes a graph to look different and how graphs look in general, all that kind of stuff, you're not gonna be able to do that very well, and your calculus is gonna suffer, because you're gonna make assumptions that aren't true. Does that make sense? So I mean, that's just one small thing. And then the algebraic manipulation. Holy shit. You learn calculus, but sometimes the first 3 steps and the last 5 steps are algebra, are college algebra, are pre-calc. Manipulation of variables, simplifying shit. One thing I tell my calc students all the time, and you ask my calc student, my calc, what does Jeff say the most? And they'll say, oh yeah, that guy, he says, before you attack it with calculus, simplify it. And the more you understand how things simplify, the more you can attack it. there's a lot of trig. I'm sorry. So I'm always curious what people say about it, misunderstandings. Obviously, pre-calculus should have a lot to do with calculus, or else there's a problem in the universe.
I
Yes.
just want to say I'm a walking example of the student that failed pre-calc and I'm back in here and I've had a calc. So
Oh, you did try to take
yeah,
it.
I tried to take calc and I failed pre-calc, so that's
So,
why I'm back in this.
How, when you tried to take it,
Yeah.
you were like,
My foundation
wait a
is-
minute,
Yeah.
no.
Yeah.
Okay. I've had students exactly in your same boat. They were in my calc class and then they transitioned to my 171 class, which is, again, basically this class, just streamlined. All right, is everybody more aware of your own advocacy as a student? You have agency. If you do fail this class, you could take Math 180 and 080. 080 is a support class. That's what the state is going to let us do instead of teaching you pre-calc. They're like, oh yeah, you could teach like a 2-unit support class. Oh, okay. But you could, you totally could. Just to let you know. Yes.
What if you pass this class? Can we still take, are we still required to take math 080 as well?
No. If you pass this class, you could take it or not. The 080, you could go straight to 180 just by itself, or you could take 080, 180 if you wanted.
That extra kind of.
And in fact, if some 176 students barely pass 176, if I were you, I might consider it. Just so I can kind of like, the purpose of 180 is to reinforce prereq skills as you're doing them in 180. Does that make sense? So the shakier your 176 foundation is, the more you should consider taking 080. If you fail this class, they're going to make you take 080.
Oh, okay.
Yeah. All right, let me stop for a minute. Somebody kind of with me. I need you to understand, I'm telling you what you can do, and I'm also trying to tell you what I would highly recommend. You can take 180 if you. Serenity's like, I've been there, people. Learn from me. Okay, all right, I'm sorry. What was I about to do? Are there any other questions from homework or anything? Okay. Real quick, who just came in, needs their quiz back? Anybody? Marcel, right? Yes. Steve? No. Marcel's? Ah. Everybody else? Is that everybody? Okay. All right, guys. So there's no other questions. Let's get back into where we left off. Can somebody remind me how many radians it takes to make how many degrees? Say again? No. That was a middle step to figure out. The whole way around the circle is 2 pi r. That literally says it takes 2 pi radiuses to get around a circle. And what does radian mean? What does radian mean?
How many angles you can make?
What word does radian come from?
Radius?
So radians is literally number of radiuses. I'm just going to keep mispluralizing it because I don't like the word radii. Are you guys kind of with me? I need you to understand this. So if I walk the effective length of 2.5 radiuses, what angle have I gone through? 2.5 radians. If I walk 2.5 radius lengths, I've gone through 2.5 radians. This is an angle measure that is physical. Degrees are made up bullshit. Are you guys with me? We are still going to talk about degrees. I don't mean they're complete bullshit. I just mean they don't really have a measurement to them. They're just a number we created out of nowhere. Okay. So we got, so anybody remember how many radians make how many degrees? Pi radians makes 180, because all the way around is 2 pi, so halfway is pi, but halfway is also 180 degrees. So pi radians goes through the same angle as 180 degrees. And that, of course, is how you translate from radians to degrees or vice versa. Are you guys with me? Just to remind you guys, how do I go from, what you got, Jeff? How would I go from like 18 degrees to radians?
Pi or
Where would degrees go? So I don't want them anymore, right? Where would I put degrees so they would cancel? Bottom. They cancel then. Yes? So on the top, I'm going to put radians, so I end up in radians. And then you just put the number in the right place. And like you just told me, pi radians, 180. Can you reduce this? So what's it become? Pi over
10.
10. Hiya! Now, I could write radians or not. If there's no degree symbol, it's understood to be radians. Or I could write RAD to make it really explicit. Are you guys with me? So if I said convert this into the other unit, what am I going from to?
Wait.
What it? Sorry, go ahead.
You said if it doesn't have a degree, it's assumed to be what?
It's understood to be radians.
Oh, okay.
So that basically I just gave it away.
Okay.
What is that? 7 what?
7 radians.
7 radians. Well, how do we know it's radians? It doesn't say radians.
There's no degree on it?
Sorry. Tomorrow's like, the thing you just said, Jeff, were you here for that? Yeah, we know it as a teacher, but maybe 20% of people heard us. All right, so 7 currently radians, and I want it to go to degrees, yes? So instructions on a test or something would say something like, for the following angle measures, convert it to the other, degrees to radians, radians to degrees. So then this problem would just say 7. And you know it's radians, because I didn't say degrees. So now, you can put this in if you want to now. What's got to go on the bottom? Radians. What goes on the top? Degrees. That's crazy. Pi radians in 180 degrees. And now that you just throw in the calculator, because pi is gross in the first place. We don't want to divide by. So let me take a guess. Well, it's almost going to be 420. It's going to be about 409.
Oh yeah, because it's divided by pi.
Yes.
Okay.
What did you get? 1200 something?
Yeah. And then
What did you get?
it's 401.6.
I never go far enough. 401 point stuff.
Yeah.
Dear. Okay. All right. So, converting between radians and degrees, easy as shit. Exactly as easy as converting between feet and inches. For the same reason.
So just to clarify, if there's a degree, we put a degree on the bottom to cancel it. And then-
Yeah, whatever unit you're in, you want to get rid of it.
Oh,
And that tells you where to put this. And then you know which place the numbers go, and then you know how to do the math right. Because if you think about it, conversions are always, do I divide or do I multiply? Well, if you do the little grid thing, it'll set itself up.
So then it just becomes 7 rad times 180 divided by pi.
Exactly.
Ah,
Okay.
you go?
Yes, sir.
Would you ever, like if you had 270 degrees, would you divide it by 360 or is it still by 180?
Oh, no. I need you. All right, listen, guys. Do you all agree that 1 foot is 12 inches? That's insane. So, like, if I had 7.3 inches, how many feet is that? What could I do? I could just put, what would go down here?
12 inches?
Inches, what would go up here? I want to kill inches, right? That's why they go down. Then I just put the numbers in the right place, and then it tells me what to do, yes? Again, my people that have survived chemistry, this should look very familiar, except we're not putting in here Avogadro's number and all that kind of crap. Okay. There's no moles coming up out of the ground. Okay. Is it also true 2 feet is 24 inches? Is that true? If I put 2 feet and 24 inches, math would look at me like this, but it would still work out because it would reduce to the same dumb thing. So could I use 2 pi and 360 instead of 1 pi? Of course you could. It's just extra. I don't need to do that. Does it make sense? You could use 2 feet 24 inches all the damn time. Why would you? You want to use it in kind of like reduced terms, yes? So that's a good question. I need you to understand. It's a good question because it's not obvious. So I there's two ideas I need to present that's related to angles in a circle. So I'm going to finally directly analyze a circle. First thing I want to ask you, all right. So there's kind of like our standard little circle. It's got a standard little angle. It's got a little radius. Oh, there's the it's like an eyeball with eyelashes. And this part of it is called the. Does anyone know what that's actually called before I say it? What this length here? It's got a specific name. It's the arc radar. No, it's the arc length. Now this is really silly. The formula for this is really dumb. Right? Not dumb in the sense that it's like, oh, dumb in the sense of course that's the formula for it. I want to figure out a formula for the arc length if I'm given the radius and the angle. Remind me what radians means. What would it mean if I said 2.6 radians? What does that actually mean? If theta is 2.6 radians, say again.
The radius of the circle.
That means I've gone the equivalent length of what? 2.6 what? Radii. Us's or radii, yeah, if you want to say it correctly. I don't. Are you guys? I need you with me. Radians comes from the word radius because radians literally means number of radii. You guys with me? What do degrees mean? Not a damn thing. They're not physical. So that's going to become really important in a minute. So what if I told you the radius? So I've gone through an angle of 2.6 radians. And that's going to be, you don't have to know this, but it should be roughly about here. And what if I tell you the radius is 7 feet? Don't overthink this. What does radians mean again? The number of radiuses. So how many radiuses length have I gone?
7 feet.
No. How many radiuses have I gone? 2.6. And how big is each radius? So how far have I gone? Don't overthink it. Each radius is 7 feet. How many of them have I walked? 2.6 of them. So how far have I gone?
18.2.
Yeah, what do you do? So if I would have made this 2, if I went 2 radiuses, how far did I go? 14 freaking feet. You guys see that? If every radius is 7 feet long, and I went 2 of them, I went 4. Okay, I went 2.6 of them. What do you do? Same stupid operation, just with the grosser numbers, yes? This is the beauty of radians. Since they are a physical measurement, they immediately give me physical measurements if I use them.
And degrees can't do that.
Sorry?
And you said degrees can't do that.
Degrees can't do yeah, they can't do that. They can't do shit, but they can't do that. So remind me, what did we just do to get the arc length? Why does it make physical sense? What do we do? What would you put in the calculator here? No, don't go there yet. What numbers will we put in the calculator? 2.6 times 7. Yes? What if I change the numbers? What if the radius was 33 feet and the angle was 1.89 radians? Would I do something different?
No.
I do the same dumb thing for the same dumb reason, yes? So now we can make a formula. Arc length. Now, here's the funny thing. I love my math people that came before me, because sometimes I wonder about them. But arc length, they said, what variable should we use for arc length? S. So arc length's variable is S. That's the best S I can make. What does this represent again? So, yeah, that was not units, but what's it represent? Radius. And what was this again?
Radian.
What did it represent physically? Not the units. What does 2.6 represent? What's the variable for 2.6? What was 2.6 physically?
The, is it
Theta, kick ass. 2.6 was the angle, yes, and the angle's theta. So what is the formula for arc length? S equals r theta. What's got to be true about theta for this to make physical sense? What must be true about theta for this to make physical sense?
Should be radian.
Has to be radians. So if some asshole gave you an angle in degrees and said, find the arc length, what would you have to do first? You have to convert it to radians. Is that hard to do? No. Okay, great. All right, I love it. So we came up with the idea of radians so that things could be physical, so that measurements could be taken. Degrees is, I mean, literally degrees is stupid. I wish we never come up with it, but too bad. Okay. So this formula is built off of the idea that this dumb word just means number of radiuses. So of course I multiply to get the total length. That's all this stupid thing says. Okay, I like it. It's not dumb. I just want you to see where it comes from is kind of silly. It's like, of course it's that. Now, this next thing I do in a very different way. I'm going to take this little triangle. Do you guys see how it's, why is this not really a triangle? This little piece. Why is it not really a triangle?
Because it's curved?
Curved. I love it. But I'm going to take that. I'm going to draw it here, this little pizza slice, yes? Is everybody with me? Now, technically, what's interesting is, how long is this? Don't overthink it. R, of course, from the center to the outside is R. So if I pretend as if this is a triangle, it's got a height of R. And what's the length of the base? We just figured it out. What's this base length? R theta. Okay. Let me stop for a minute. That's what we just calculated, right? So the R and the theta were there. I just kind of took that pizza slice and put it down in front of me, and instead of eating it, I'm staring at it. We just calculated that's R theta. So what is the area formula for a triangle? Let's pretend like this is a triangle for a second. What's the area formula for a triangle?
That's 10.
Huh?
For triangle, right?
What's the area of a parallelogram? Do you guys remember? What's the area of a rectangle? If I write B and H is B times H, yes? Now if I cut a triangle out here and move it over there, don't I make this? Doesn't it have the same area then? What's the area of this parallelogram? Base times height. What's a triangle? Half of that. So what's the area formula for a triangle? 1/2 base times height. Half height base, half height base. All right. If I pretend like my pizza slice is a triangle, and you all agree it really isn't, it's got a bit of a curve at the bottom, right? But if I pretend like it is, what would I get for the area of this pizza slice? What did we say the base sort of is like?
It's
R theta. And what's the height?
1/2.
R, so I get 1/2 R squared theta. That is the actual formula for the sector's area. I might have just used that word for the first time. This pizza slice is called a sector. Sector of the circle, right? Stop it. The reason this works is sort of like I can take some stuff from the inside and put it on the outside. I can kind of like reorganize this so this does become flat, and it would still work out. There's actually a more technical reason why this works.
But is it's an R right before the theta, right?
Yeah, I made R theta look really weird. Is that better? There. Is that better? Okay. All right. I don't know if I ever told you about the teacher I had that he would write, and somebody would say, "What did you write at the top?" And he'd say, "Does somebody remember what I wrote? I can't read it." If I ever get to that point, I gotta stop. So what's the arc length formula?
R theta.
Arc theta. Why does it make sense there's a square in the area formula? Because area is in what kind of units? Area involves how many dimensions? Area involves how many dimensions? Alright. You guys see the floor? Everybody look at the floor. Everybody look at the floor. Look at the floor. Everybody. Look at the floor. I can tell if you aren't, because that means you're not looking down. Look at the floor. Do you guys see rectangles?
Oh, yes.
Yes. Yes? Does it have a length? That is one dimension. A length is one dimension. Does it have an area? It's length times width. That is how many dimensions? 2. And if I did volume, that would be 3. We're not doing volume yet. Keep that. You guys with me? So I expect area formulas to have squares in them or to have like length times width. So I end up with square units because that's literally measuring in how many squares you can fit. Okay. So we got our two little formulas here, arc length and area of a sector. Yes? Okay. And I think, yeah, that's perfect. Oh, one last idea. So we got these two formulas.
And so that's area of a sector?
Area of a sector. You can think of it as area of a pizza slice. Area of a slice of pizza, right? Okay. Can you guys, if this is 0 degrees, can you guys estimate where 120 degrees would be?
It would be a little past the 90 degrees.
Yes. So this obviously would be 90. So then visually, you would just, here's halfway, you wouldn't quite go halfway. So this would be roughly 120 degrees. Is everybody with me? Now, what's kind of dumb is, in history, we made a choice. We made so many choices, and so many of them were bad. We decided, for some reason, that we would measure angle going counterclockwise. Do you guys see that? You guys see that? If I want to go 120 degrees, I go counterclockwise. Where would 480 degrees be? How much is a full rotation?
360.
360. So then how do you figure out where 480 would be? Does 480 degrees have a full rotation in it?
Yes.
Okay, so to get to 480 degrees, wouldn't I have to go all the way around, and then how much more? So do you see how 480 is in essence the same angle as 120? Do you guys see that? In fact, how many angles could you get that are in essence the same as 120? You can just keep doing that forever until you go insane, right? You're like, I got beat up already insane. Okay, great. How you guys doing? This is the idea called coterminal. Where does 120 degrees terminate? Here. Where does 480 degrees terminate? Same place. So we call them coterminal angles. 120 and 480 are coterminal. What would a negative angle mean? I'm going the other direction. So can you estimate where negative 70 degrees is? Try to put that on the circle that you're definitely putting in your notes. Where would negative 70 degrees be?
Would it be opposite?
Sorry? So now I'm starting out with 0, yes? But instead of going in the positive direction, I'm going to go in the negative direction. And 70 is just before 90 roughly, so this is my guess for negative 70 degrees. Are you guys with me? What is a positive coterminal angle with negative 70 degrees? What angle is coterminal with negative 70 degrees, that is positive. Huh? Oh, 200, yes. I mean, how would I do it? How do I find coterminal angles? I rotate by 360. If I go full, all right, you all agree that if this is 0 degrees, I'm now facing in a certain angle from that. If I then do a full rotation, I'm of course facing the same way. If I do 3 backwards rotations, why am I doing this? I'm still facing the same direction, but now I'm very dizzy. So I could go forward 360, I could go backward 360. I'm always going to end up in the same place. Let that be really silly. Of course you are, right? So if I'm given any angle in the universe, how do you find coterminal angles? You add 360 or you subtract 360. That's rotating the full thing one way or rotating the other way. So I would do negative 70 degrees plus 360 degrees. And that gives you 290 degrees. So 290 degrees ends up in the same place as negative 70 degrees. Okay, that needs to be a remarkably simple idea. What would be a negative coterminal with 120?
So it'd be 120 minus 360?
120 minus 360
Oh, yeah.
is? What's 360 minus 120? Yeah, so it'd be negative 240. Good. Let that be easy. If I say find the coterminal angle, before you finish reading that question, you oh, thank the gods. Yes. Just have to add and subtract 360. Yes, let that be nice. With that said, here, I'm going to give you a problem where it asks you that. You read it. Blah, blah, blah. Yes, okay, beautiful. So please work on this handout. Start off by yourself. This basically covers everything we touched on today.
Was this for section 7.2?
In the interest of time, because I do want to do one more thing after this. Is everybody cool? Everybody like really, really cool with these? I mean, these have to be nice. And I normally give you a few that reduce nicely. So like here the zeros die. You could divide these both by 6, yes? So then you get 4 pi over 3, is that cool? And you don't have to write anything, or you could write rads, it's up to you. This one, now let me do this the long way. Whenever you have a fraction, you can always put it like this in the grid. And then I have to put radians down here, degrees up here. But do you see how pi will always just cancel? So the shortcut is just right off the bat, replace pi with what it is. You can just replace pi with 180 degrees. 180 divided by 6 is 30, times 5 is 150. Real quick, what's a full pi? How many degrees is a full pi?
20.
So does it make sense that 5/6 of a pi is a little less than 180 degrees? Do you see that's what just happened? That just makes nothing but sense. Okay. That might become important later. What the hell's going on here?
It's the
So what goes where?
pi goes on the bottom.
Pi goes on the bottom because it's radians. How do I know? Because it's not degrees. And on the top goes 180, and then whatever the shit that is. Let me see if I can give a stupid attempt at it. Hold on. So it's probably 647. What is it? I never go far enough. 630? 0.25. Okay. 630.25. Wave your hands. Okay. Degrees. Don't forget to put the units. Do you guys understand? I'm going to have to take points off if you don't put degrees when you mean degrees, because then you mean radians. If you don't put degrees, you mean radians. So be really careful. And then finally, I end up with another not too bad one. Degrees on the bottom, radians on the top. These reduce nicely. Is that 11/6?
Yes.
Go, Jeff. I'm going a little fast, but oh well. 129 degrees. How can I get two coterminal angles? Yeah, I can add 360. So that would be 489. And then I could subtract 360. And that would be 231 negative.
Yes.
Yay, Jeff. That has to be nice. Arc length, S equals R theta. Area, A equals 1/2 R squared theta. Do I plug 80 in for theta? What's wrong with this?
Not radians.
Yes, it needs to be radian so it makes physical sense. So 80 degrees divided by 180 times pi, and I get, what is that, 4 pi over 9? You guys with me? Don't make this a decimal, because then two things. You have to write the whole damn decimal in your calculator, and you're rounding, so your answer is going to be wrong. So then the arc length will be R times theta. So whatever the shit that is. Now that you can plug in the old calculator. Give it a try, Jeff. I don't know, man. 13, it's like 40, 52. It's probably more than 52. 55. No, it's more than that. I don't know what the hell that is. I'm going to stop pretending. I'm going to say 55. Has anyone done that yet? That's the closest I've been yet. Okay, maybe I'll stay in this job. 53 point blah, 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 blah.
0.05.
What's the units?
Is it?
Inches, yeah, it's length, so it's inches. Yep. And then here we figured out what theta is, yes? So I've got most of it done already. And then I just got to plug all that shit in the calculator. You want to do that in your head, Jeff? No, but I'm going to try anyway. I lost track, but it's around 360. I think, did I remember to cut in half? I think I did, yeah. So it's 4, 19, 80, 320, 160. So I'm going to say 971.
What'd you say?
I said 971.
It's 1,008.1.
1,008?
Yeah.
Okay. 0.2 blah 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 blah. And what's the units on that? What's 38? What's the units on 38?
Inches.
And what did we do to it?
We squared it.
So what's the units here?
Squared.
Which makes sense because it's area. Okay. All right, we'll have time. Good. Too bad for you guys. This last one's a little bit tricky for two reasons. If find the area. Okay, area is 1/2 r squared theta. So what do I need to know to get the area? I need to know two things. What two things?
I need to know the rate.
Do we know the radius?
Yeah.
Check. And we also need to know
The
the
theta.
angle. Do we know the angle?
Oh,
No. But what other information do they give you?
S,
I said the arc. Oh, okay, what's the formula for the arc length?
S equals R times theta,
All right. Do we know the arc length?
28,
Do we know the radius?
7,
Can we solve for theta?
by dividing by 7.
Now, one little thing I have to give myself shit about is that's more than a full circle, but that's okay. It's kind of like a pizza with part of a pizza on top of it. So the total area will be a full circle plus a little more. No, actually, what am I talking about? No, I'm fine. No, it's not a full. Yeah. I'm sorry. 4 is fine. It's a little more than half the pizza. So how do I figure out the area?
1/2
Yeah, 1/2, and the radius I told us from the beginning.
squared.
And the angle we just figured out, 4. So that is 98. Yeah, that I can get exactly. Oh yeah. Good job, Jeff. 98 what? Squares. I like it. So of course, number 4 was a classic math problem. Math teachers love the multi-step problem. Okay, so the last thing for today. Oh yeah, I got 5 minutes. What do you guys think? We're good. There is a beast called the unit circle that I don't care too much about. If you ever took trig before, you had to fill in a blank unit circle. I will never make you do that. This is dumb. This dumb is so dumb. I do not. My colleagues are like, yeah, unit circle. I don't see the utility in it. But we have to talk about it, of course, because it's kind of like the thing behind Pythagorean theorem. Well, not cosine squared plus s squared 1, blah, blah. It's behind a lot of different stuff. So if I go through an angle, I end up at a point, yes? So if I go through an angle, I end up at a point. This point is xy. Does everybody agree with me? Because I don't know what the shit they are. I just know it's xy. Where is x by itself? Where is x? How do I get to this coordinate? Don't overthink it. How do you get to that point? If I tell you the point's 3, 4, what do? You go over 3, up 4. Yes, so how much do you go over?
X.
X, crazy. Yes? And then you go up.
Y.
Y. What shape have I just made? A right triangle. So what lives inside of every circle are a bunch of right triangles, which is trig, which is why the unit circle kind of has trig function stuff living in it, because it's got right triangles living in it. Not an immediately obvious thing, but once you draw it, you're like, holy shit, there it is. If this is a unit circle, does anyone know what that means? It's an absolute unit. No. What does unit mean? If I said I have a unit of something, how many do I have? Does anyone know? Huh? 1. So we call it a unit circle because unit references the number 1. So this would be a circle with radius 1. Is everybody with me? No. Okay. So if I have a unit circle, can somebody tell me what sine theta is? How long is this? How long is this here? Here. Why? Because I want to know. So what is sine theta then? No? Y over 1. So sine theta is y. What's cosine theta? X over 1. So it's x. Okay. So when the hypotenuse is 1, of course these guys are just directly equal to, and this is more in your face why I say sine likes y, cosine likes x. Because fundamentally, when I reduce everything down, sine is y and cosine is x. So SOHCAHTOA can suck it. I'll be right. If you like SOHCAHTOA, it's fine. It still works. So here, I want to get a little deeper in this. A little deeper than I can. All right, I'm gonna do one thing for damn sure. So if I have a unit circle and I go to 60 degrees, yes? Does anyone remember what the sine of 60 degrees is? Yes. And what's the cosine of 60 degrees? 1/2. So these we're going to memorize. If I go to 120 degrees and I draw my circle really sucks, but I'm going to be okay. If I draw this triangle, these two triangles should be what? Now, real quick, if I go 120 degrees, can anyone tell me how big this angle is here? If I go 120 degrees, how big is this angle? How short am I from 180 if I stop at 120? 60 degrees away, yes? Do you guys see how this triangle is the same as this triangle? They are the same triangle. They are both 30, 60, 90 triangles with a hypotenuse of 1, yes? So what should sine of 120 be if they are the same triangle?
Square root of 3 over 2.
Now, cosine of 120 is not 1/2 for one simple reason. What is cosine like? What does cosine go as? Cosine goes like x. What quadrant am I in?
Y.
What quadrant am I in? Second one. What's true about x here? It's negative. So cosine of 120 is negative 1/2. So this, we're obviously going to do more of this. This is called this is called a reference angle because it's in reference to the x-axis. Damn it. I'm over again. I love it. I just talked too much today. All right. So, Monday we'll hopefully finish up chapter 7. We'll probably have another quiz on Tuesday because our next test is Thursday. We might not make it all the way through chapter 8, and I'll announce that if that's true. But we'll see how it goes. So I'll see you all next week. Mm-hmm.